I was trying to figure out what was going on in my own childhood. Why did I enjoy so many privileges and such opportunity, and those vis-a-vis my neighbors who didn't? And so little did I know that when I was asking these questions, I was asking a very fundamental question about nature versus nurture. So if I really wanted to answer that question, here's what I'd have to do, right? I'd take two identical twin embryos, I'd raise them in exactly the same conditions, I would take these two twin babies at birth, I would put one in the inner city or in a poor Appalachian small town, and I'd put the other in a rich community, let's say Greenwich, Connecticut. Since I'm from New York, that's the wealthiest nearby community. And then for about 35 years ago or so, I would stalk them in the bushes, taking extensive notes about how they were doing, what they were doing, and then in about 35 years, I'd have my answer, right? Because they're genetically identical, and I would be able to say what's the role of their environments. And in fact, actually, I'd need an army of teams of research assistants because I'd have to do this about at least 35 to 40 times. And if I want to know anything more, like the effects of race or gender, I should say, I'd have to vary the twins and all that, and I'd have to have statistical significance. So you can see it's not going to happen. My kids are very happy that they're not twins because they know that I would be experimenting on them all the time. Do identical twins experience life and get treated more similarly than do fraternal twins? What would you say? Probably yes, right? I mean, half the time, if you have identical twin friends, they're playing a trick on you that you don't even know which one is which. They're often dressed alike. They are more in touch with each other. So we know that they experience more similar environments, not just more similar genes, and therefore we're back to square one and trying to understand, parceling out nature and nurture. With this genomics revolution, what happened was that folks went back and they tried to say, well, now we know what the genome looks like. Let's actually try to, instead of relying on these twin assumptions and all these unmeasured genetics, let's measure genetics. Let's measure everybody's genome, like 23andMe, and see what we can explain. And so let's take height, for example. Turns out height, the general estimates for adults is that height is about 80% heritable, 80% genetic. But they could only explain 5% of the heritability of height by sequencing across 1 million markers your entire genome. So what's going on? So it's called the case of missing heritability. But here we have another mistake of sorts, which is that about 18% of twins in these national data are wrong about whether they're identical or fraternal. They've grown up thinking, the vast majority grow up thinking of the wrong ones, grow up thinking that they're fraternal, look differently or whatever, but they're actually identical. And so when you do that, you can say, well, they lived in a social regime where they thought they were fraternal and they're actually identical, or vice versa. And therefore, you can disentangle the environment and the genes. And what do we find? I went, as a social scientist, I went at this ready to prove that all of the genetics were overstated and the environment mattered much more. But you have to be an open-minded empiricist, and what did I find? I looked at a series of outcomes: height, ADHD, which many of us suffer from, GPA, depression, and so forth. And in no case did I reduce the genetic heritability of these traits. In fact, in many cases, it went up. So I had to admit defeat as a social scientist for this particular battle and say that the original estimates were probably fairly accurate, but that still leaves the missing heritability problem that we have to figure out where in the genome is predicting these things. Well, maybe the twins that think of themselves as different or think of themselves as more similar than they are genetically are doing that because they are more similar in their grades or more different in their grades or their height or their weight. And therefore, it's actually the thing I'm trying to predict, their similarity or difference in these outcomes, that's driving their classification, not the other way around. But when I go back, I looked at birth weight, how much you weigh when the doctor slaps you on the scale right when you come out of your mother. And this is the only outcome for which the misperceive, those who think that they're fraternal twins and they're actually identical twins, resemble each other a lot less. They only resemble each other 40% compared to the correctly classified ones that resemble each other 80%. Therefore, we hypothesize that actually at birth something happens. If one baby is huge and fat and the other is a little shrimp, then they think, well, these can't be identical twins. They must be fraternal twins, and they start living their lives that way. And their parents treat them that way and so forth. And therefore, it's not an issue of what we call reverse causality. Through social surveys, sometimes when you combine them with genetics, you can answer very fundamental, interesting questions, or I shouldn't say answer, because sort of temporarily resolve, because there's never an answer. That's another thing about science that we haven't talked about very much, that there's nothing that's not up for debate. And there's no answer to one question that doesn't raise 4 other questions.